Hello everyone. Today we shall discuss about simple harmonic motion and uniform circular motion. So we are describing about simple harmonic motion and uniform circular motion. Simple harmonic motion, simple harmonic motion, harmonic motion and uniform circular motion and uniform circular motion and uniform circular motion. What is the difference that I am going to discuss with you? Circular motion. सबसे पहले हम देखेंगे कि सिंपल हार्मोनिक मोशन और यूनिफॉर्म सर्कुलर मोशन में क्या डिफरेंस है. क्या यूनिफॉर्म सर्कुलर मोशन एक सिंपल हार्मोनिक मोशन है? नो. यूनिफॉर्म सर्कुलर मोशन इज नॉट a simple harmonic motion. So why we are reading the simple harmonic motion and uniform circular motion at the same time? Actually we will get a difference thing, that is a particle moving in a circular motion. We take that particle as a reference particle and we take that circle as a reference circle. If we take that particle as reference particle and the circle as reference circle, then it can be treated as a simple harmonic motion. क्या इसका मतलब है? Suppose we have taken axis x and y axis. So this is x axis, right, and this is y axis. This is y axis. This is y axis. And we have taken a circle, right? So here we are taking a circle here. So we have taken a circle here. यहाँ पर हम एक सर्कल लेंगे. वी आर टेकिंग अ सर्कल हियर. इसी and we have to change the color also. We are changing the color as white or yellow color. अच्छा, इसे हम अभी मिटा देते हैं और अब हम देखेंगे कि हाउ दिस यूनिफॉर्म सर्कुलर मोशन एंड सिंपल हार्मोनिक मोशन आर रिलेटेड विद ईच अदर. So we are taking an axis. One is x-axis in the middle. So if this is the middle line, though this is the x-axis, right? And here we are taking a vertical line that is treated as y-axis. This is treated as y-axis. Actually, what we are taking, we take this circle as a reference circle. Reference circle, and we can take a particle here and we take this particle as a reference particle. Reference particle. If we take this circle as a reference circle and take this particular reference particle, then you can say that this particle is executing simple harmonic motion. But remember that uniform circular motion is not a simple harmonic motion, right? यहाँ पर हम लिख देते हैं कि uniform circular motion, uniform circular motion, uniform circular motion is not a simple harmonic motion. SHM is not SHM. Why are we reading then uniform circular motion? If we take the projection क्या होता है? जैसे एक पार्टिकल यहाँ पर है, right? And it is moving in the anti-clockwise direction. इधर जा रहा है, in this way, right? And if we find the position vector of this particle P, position vector is always from the origin, this one. So this is the position vector of this particle. ठीक है, ये हमारा पोजिशन वेक्टर है ऑफ दिस पार्टिकल P. ठीक है, तो दिस एंगल इज नोन एज फाई. फाई मीन्स इनिशियल फेज होता है. फाई मीन्स इनिशियल फेज. इनिशियल फेज. What we know that the particle is starting from here, right, and goes to at a certain time t. So there at that time the initial phase is phi. That means at time t equal to 0, the particle is here at this point phi. And if we take a projection क्या होता है? Projection means if we give a light here, the shadow of this particle will fall on this x-axis here, right? You see, this is straight line. The shadow of this particle will fall here. In the same way, when the particle is at this point, the shadow of this particle will fall here. The same way, if the particle is at this point, the shadow of this particle will fall here. If the particle is at this point, the particle will be at here. And you see, this is the mean position, or what you say it as equilibrium position. And the particle is here, then its projection will fall here. If the particle is here, the projection will fall here. If the particle is here, that is the extreme position. And here it crosses. You see here, if it crosses is that this particle crosses this one, the projection of this particle fall here. The position of this particle fall here. And if we take the projection of this particle, the projection will be here. The position of this particle position here, and the position of this particle falls in this position. Projection of this particle from in this direction will fall here. So this is executing simple harmonic. This particle, if we take a projection, अगर हम ये particular projection लेते तब हमको लगेगा कि ये एक simple harmonic motion की तरह कर रहा है. लेकिन this uniform circular motion is not an SHM. अगर हम projection लेते हैं तब इसे simple harmonic motion हम मान सकते हैं. Projection on this x axis or maybe y axis. हम कोई भी एक्सिस ले सकते हैं, कोई भी डायमीटर ले सकते हैं. तो डायमीटर के ऊपर जो प्रोजेक्शन होता है, जो पार्टिकल इज मूविंग, सो दिस पार्टिकल, इसके हम बोलते हैं रेफरेंस पार्टिकल. नॉट दिस पार्टिकल बट इट इज़ ए रेफरेंस पार्टिकल. और ये सर्कल को बोलते हैं रेफरेंस सर्कल. तो दिस इज एग्जीक्यूटिंग सिंपल. यू सी हियर, दिस इज गोइंग टू द मीन पोजीशन. हियर it is going, suppose in this way, right? The particle is moving in this direction. Here in this direction, this is the mean position. It passes the mean position and it goes here, and this is extreme position. After this, changes its direction. This projection is here. It goes here. It goes here. It again go to the mean position. It goes to the next particle, to the next particle, the next particle. Again the extreme position. And this particle will go back to this position, this position, this position, this position. So it is executed simple harmonic, not the uniform circular motion. So why we are taking this circle? Because we are taking this circle as a reference circle and taking this particle as a reference particle to find the equations of motion of simple harmonic motion. Now see what we are getting here. So in the process we are observing, in this process, what do you find? In this process, in this process, in this process, in this process, what we are observing, what we are observing, what we are observing, we are observing that what we are observing in the motion of the ball, in the motion of the ball, the motion of the ball on a diameter of the circle, on a diameter of the circle, normal to the direction of view, normal to the direction of viewing. अगर हम प्रोजेक्शन करते हैं, and that projection is acts as a simple harmonic motion. And here we can find that the radius of this particle is a, right? Suppose the radius of this circle is a, or what we call it as amplitude. Amplitude क्या होता है? Amplitude is the maximum displacement of a particle from the mean position. Displacement हम कहाँ से count करते हैं? Always from the mean position. Remember that. Displacement we always count from the mean position or equilibrium position. That is important for us. So on the diameter of the circle, normal to the direction of viewing. So what we are getting, that is this figure 1. Figure 1 describes the same situation mathematically. And let us suppose, we have already mentioned, let us suppose a particle P is moving, a particle P is moving uniformly on a circle of radius a with angular speed omega, with angular speed omega. Right? So the sense of rotation is anti-clockwise. Here we have taken the sense of rotation. The sense of rotation is anti-clockwise. Here we have taken as anti-clockwise. So the projection is on the x-axis, right? The projection is on the x-axis. So what we get, that the initial phase of the particle vector, the initial position vector, the initial position vector of the particle, the initial position vector of the particle, that is the vector OP, here O, this is the origin O, vector of the particle, that is the vector OP, the vector OP at time t equal to 0 makes an angle phi, with the positive direction, with the positive direction of x, with the positive direction of x-axis, positive direction of x-axis, positive direction of x-axis. In time t, it will cover a further angle. It will cover a further angle. Cover a further angle omega t, and its position vector and its position vector and its position vector will make an angle make an angle of omega t plus phi with the positive x-axis, with the positive x-axis. ठीक है, दिस इज द फाई. अगर ये टी टाइम में ये यहाँ पर जाता है तो इसका जो एंगुलर वेलोसिटी होता है ओमेगा टी, ओमेगा स्पीड, एट दिस पर्टिकुलर इंस्टेंट ऑफ टाइम टी, तो दिस इज एंगल ओमेगा टी, राइट. दिस इज ओमेगा टी. So the total angle is omega t plus phi. So the vector will be from here to here, right? This is the, so the position vector of this vector will be a omega t plus omega phi is the positive x-axis, right? Now if we consider the projection, right? Next consider the projection of the position vector. Next we will consider the projection of the position vector. Consider the projection of the position vector OP, position of the position vector OP on the x-axis. This is the projection, right? This will be OP dash. Suppose this is the projection vector and we get it value as OP dash. This is the OP, right? P dash. So we have taken a P dash here. P. This is so we are projecting this particle, and this will be P dash. Right? This was the P dash. So let us take this angle as A. This is A, and this is omega t plus phi. So if we take a projection of this particle on here, of this particle, suppose this particle is this is P1, this is P2. So the particle position P2 will be here. So this is the value of projection, and this position is x. So we can write it here as that this will be projection is O P2 dash, right? So the projection will be the projection will be O P2 dash. So the position of P2. So the position of P2, the position of P2 on the x-axis, as the particle moves on the circle, moves on the circle, moves on the circle is given by, see here, this is x, right? This value is x. So x, function of time, it can be written as a cos omega t plus phi. How? You see, we are again explaining this one. So this is a circle. So right, this is a circle. This is the x-axis, right? A particle was there here. This is the center. So the particle initial phase is this one. This is P1. The projection will be here, right? If this particle, this is y-axis. If this particle goes here, so it will be P2. And the projection of P2 will be, this is the position vector, the projection will be here, right? So this angle is omega t plus phi and this radius is a. So the projection is a cos omega t plus phi. So this distance, that is x, is equal to a cos omega t plus phi. So we learned that the projection in this way, that this a cos omega t plus phi defines the displacement of a particle, and it executes a simple harmonic motion only if we take this circle as a reference circle and take this particle as a reference particle, only then. But uniform circular motion is not a simple harmonic motion. Remember that. But if we compare the projections of a particle moving in a circular motion, then the projections can be considered as a simple harmonic motion, right? So what we are dating, so this is the way we a cos omega t, which is defining equation of the SHM, that is a xt a cos omega t, which defines, which is the defining equation of equation. So this is the equation of SHM, right? So we got the equation as xt is equal to a cos omega t plus phi as the defining equation for simple harmonic motion. This shows that that if P moves uniformly, that if P moves uniformly on a circle, its projection P dash, its projection P dash on a diameter of a circle, P dash on a diameter of a circle, executes simple harmonic motion, right? Simple harmonic motion. So we call this particle as a reference particle and call this circle as a reference circle. Only then it be considered as a simple harmonic motion. But remember that uniform circular motion is not a simple harmonic motion. The particle P and the circle, the particle P and the particle P and the circle, the particle P and the circle on which it moves, are sometimes referred to as the reference particle, and the reference circle, and the reference circle respectively, and the reference circle respectively. We can take projection of the motion of P on any diameter, say on the y axis. We can take projection of the motion of P, projection of the motion of P on any diameter, on any diameter, say the y-axis, say the y-axis, y-axis is given by is given by is given by y is equal to a sine omega t plus phi. This is the equation on the y-axis, and on the x-axis it x equal to a cos omega t plus phi, which is also an SHM, which is also an SHM, of the same amplitude same amplitude as that of the projection on x-axis, but differing a phase, differing by a phase pi by 2, that is 90 degree, right? So x is in this direction but y is in this direction, so there is a phase of 90 degree here. You see here, this is a phase of 90 degree or pi by 2. In spite of this connection between circular motion and SHM, the force acting on a particle in linear is very different from the centripetal force, right? In spite of this connection, in spite of this connection between circular motion and SHM, that in circular motion, the force acting on a particle, the force acting on a particle, in linear simple harmonic motion, linear simple harmonic motion is very different from the centripetal force, needed to keep a particle in uniform circular motion, Yes, because we already know that uniform circular motion is not a simple harmonic motion. It can be considered only when the particle has a projection on the diameter, then and the particle is referred to as the reference particle and the circle is referred to as the reference circle. Only then that projection of the particle on the diameter is considered as a simple harmonic motion, right? So uniform circular motion is not a simple harmonic motion, but the projection of a particle which is executing uniform circular motion on the diameter is same as that of simple harmonic motion. And what we find, the equation for simple harmonic motion, x equal to a cos omega t plus phi in the x direction, and for y, on the diameter of y, it will be y equal to a sin omega t plus phi. So this equation we got, right? So in this way you can find the equations of motions, simple harmonic motions, with comparing with uniform circular motion. So what we get at the end, that the uniform circular motion is not a simple harmonic motion, but the projections of a particle executing uniform circular motion, projection on the diameter is considered to be a simple harmonic motion if the particle is considered as a reference particle and the circle is considered as a reference circle. Thank you everybody for watching this video.